So we looked at how to graph a piecewise function, and now we're going to do the opposite and learn how to write the piecewise function given the graph. Here are the steps for writing a piecewise function. So first you want to find the equation of each line. So to do that, you're going to find 2 points on the line, you're going to find the slope, and then you're going to use the point and the slope to find the linear equation in slope-intercept form. So to do that, you can use slope-intercept form from the beginning, or you can use point-slope form. Then we're going to find the boundary points, or the endpoints, for each equation, which will be used for the inequality. Remember that an open circle, we're not going to have the included line with the inequality, and a closed circle, we do have the included line under the inequality. And then we put it all together and we write our piecewise function. So here's an example of one. So I'm going to set it up by making my piecewise function over here. So you can use f of x, you can use y, and then we have this little bracket. So remember that the topmost function in your piecewise function has to correspond to the leftmost piece of your graph. So this graph here, we can see that that's just the horizontal line of y equals 1. So this one you can kind of just look at and know what it is. If you want to actually pick 2 points, you can pick, let's say this point, -2, 1, and you can pick another point on this line, so let's say -4, 1. And then we can find the slope. And just to remember, the slope is the change in y over change in x. So y2 minus y1 over x2 minus x1. And then you can plug it in and you can solve for your equation. So you end up with y equals mx plus b. So in this case, it's just a horizontal line. So that's going to be y equals 1. And then we're looking at our endpoints. So here we can see that there's a closed circle here at -2, and the graph goes to the left. So it's going to extend infinitely in the negative direction. So we're going to say, I'm just going to write the word if. You can put the word if or not. And then here's my inequality. So it's going to be x is less than or equal to -2. So every x value that's less than or equal to -2 will be part of this equation, part of this line. So now for the second line, I have to find that equation. And you can do this one of 2 ways. You can look at the graph and count. So let's do that first. And then I'll do it the longer way. So here I can see the y-intercept. It's crossing at 0. So my y-intercept is 0. And if I count my slope, up 1 over 1, up 1 over 1, my slope is 1. So this equation should just be y equals x. Okay, if you're not sure how to get that, pick 2 points on the line. So here we have an open circle. So that point is -2, -2. And then pick another point on the line. I'm going to pick 0, 0. Okay, so if you wanted to do the slope, and I'll just show this out really quick for those of you that need it, we have y2 minus y1, so 0 minus -2 over x2, so 0 minus -2. These become pluses here, so I end up with 2 over 2, which is 1. So the slope is 1. And then if I use point slope form, which I think is the easiest way to write our equation, point slope form is y minus y1 equals m times x minus x1. Okay, that's point slope form. If I pick a point, so out of these 2 points, I'm going to pick one. I'm going to pick this one because it's easier to use. I'm going to plug it in for the y1 and the x1. So I have y minus, the y value here is 0, equals m, which we found was 1, and then x minus the x value, which is 0. So if I do y minus 0, I end up getting y. And then here, if I distribute 1 times x, we get x. And 1 times -0 is just 0. So we end up with y equals x, which is what we have up here. And then if we look at our endpoints, we can see that we have an open circle here, and this x value is -2. And then it continues going to the right infinitely since we have that arrow at the end. So for our inequality piece, we have all values of x that are going to be greater than -2. So x is greater than -2, and it's not going to include -2 since we included it in the previous one. So it has an open circle, so it has no line underneath, but also the one above it has the included symbol, so this one does not. Okay, so let's look at one more example. Okay, so here Okay, we have 3 pieces. So even though it might look like there's 2, there's really 3. So let's kind of outline them a little bit. So we have this piece, this purple piece, and then we have this blue piece, and then we have this red piece. So we have where the purple and the blue connect, we have a shared endpoint. So remember from one of the earlier slides, you can't have both endpoints be included or not included. So one of them will be a hole and one of them will fill the hole. So when we get to rating those, we'll talk more about that in a minute. So here we have f of x equals. So now I have 3 pieces. So this first piece, again, we have this horizontal line. So since I have a horizontal line, I can just use the y value of that, okay, which is 4, right? So this is just the horizontal line, y equals 4. So 4 is my function. And again, you could pick points on that line and find the slope, but because it's horizontal, the slope will be 0. And then I'm going to say if. Now here we have endpoints. So notice that there is a dot here, okay? So it's stopping there, and then here where they intersect, the purple and the blue intersects, because we don't know which one is open and which one is closed, we can decide what we want. So let's say that the top one, the top function, so this 4 is going to include this point, okay? If you decide it doesn't include the point and the next one does, great, okay? So here we have the x values are between -7 and -3. So I'm going to say -7. Since it's a closed circle at -7, I'm going to have the equal to sign, so less than or equal to x. And then we said it's going to include the -3. So we'll use the included bar underneath. So less than or equal to -3. For the blue line, okay, again, we can either look at the line and figure out the y-intercept here is -2, and we can count the slope. So it's down 2 to the right 1, or you can say up 2 to the left 1. So this slope should be -2, and then the y-intercept is -2. So the equation would be -2x minus 2. Okay? Or we can pick points. So I'm just going to do it both ways. So if I use this point, let's say here, so this is the point 0, -2, and then I pick one more point on the line. So I'm going to pick this point. That's the point -1, 0. Okay, if I want to find the slope, I'm going to do change in y, so 0 minus -2 over the change in x, -1 minus 0, and this is going to give me 2 over -1, which is -2, which is my slope, which is in front of x. And then I'm going to, again, I'm going to use point slope form, so I'm going to do y minus, I'm going to pick this point here, no reason why, but pick that point, y minus 0 equals the slope of -2 times x minus the x value of -1. So again, y minus 0, that's y. If I distribute this, I'm going to get -2x. This really becomes a positive 1. So -2 times positive 1 is going to be -2. So that is the same thing that we got by just counting the slope and looking at the graph. So here we have a closed circle here, and then because the previous one had a closed circle, the blue function has to have an open circle at this point. So that's from -3. So I'll put if here. -3 is less than x, and it includes this point, so less than or equal to 1. Okay, so whenever you leave off on a number in the inequality and you pick back up on it in the next equation, you want to make sure that 1 is included and 1's not. So if you wanted to make the blue one included, great, put the included here, but then in the one above it, take that one away. Okay, so it does not matter. So now I'm just going to leave it like that. I changed it up. And then for our last piece, this red piece, this one's a little bit harder to just look at and figure out because it's not crossing the the y-axis. So we can figure out the slope by counting it and then count it to figure out the y-intercept. But in this case, I'm actually just going to pick 2 points and find the slope. So I'm going to use the open circle point. So that's the point 1, 3. And then I'm going to use this point down here, which is 7, 0, that closed point there. So I'm going to do the slope is change in y, so I'm going to do 0 minus 3 over the change in x, so 7 minus 1. So this gives me negative 3 over 6, which is negative a half. So my slope is negative a half. I'm going to again use one of these points. So I'm going to use this point again. I always try to pick the easiest point to use. So if there's a 0 somewhere, I'll probably use the point that has the 0. I'm going to do point slope form. So I'm going to do y minus the y value, so 0, equals the slope, so negative 1/2, x minus the x value, so 7. So y minus 0, again, is just going to be y. I'm going to distribute the negative a half. So I have negative 1/2 x, and then negative a half times negative 7 is positive 7/2. So this one doesn't look as nice because there's fractions involved, but hey, it's the same steps. So we are good with fractions. Okay, so there's our last equation. And then we have to write the inequality for this. And we can see that there's an open circle when x is 1, and then we have a closed circle when x is 7. So it's going to be 1 is less than x, which is less than or equal to 7.